So hello everyone, and happy Saturday to you. As you might be aware, many students, and I knew this was going to happen, asked me to go over a video with the equations, basically the three equations I did in chapter 5. So I'm going to do that now, and I'm going to apply them to Excel. So the first one I want to do, and this is probably the most toughest, is equation 5.1. And you'll notice here, in general, we can convert. Now I'm in your textbook, by the way. We can convert a discount rate of R for one period to an equivalent discount rate for n periods using the following formula. So this is an important equation, and I want to make sure everyone's aware of that. And this is a general equation. All right, so you notice the title, general equation. And all it is equivalent end period discount rate is 1 plus R raised to the number of periods minus 1. So the important point is, you see what it says. In this formula, n could be larger than 1 to compute a rate over more than one period, or smaller than 1 to compute a rate over a fraction of a period. So this could be a lot smaller or larger than 1. When computing present or future values, it is convenient to adjust the discount rate to match the time period of the cash flows. This adjustment is necessary to apply the perpetuity or annuity formulas as shown in example 5.1. And here's example 5.1. All right, so suppose your bank account pays interest monthly, right, every month, with the interest rate quoted as an effective annual rate, EAR. Remember we talked about EAR. Now that's equation 5.2, which we'll get to later. What amount of interest will you earn each month? If you have no money in the bank today, how much will you need to save at the end of each month to accumulate $100,000 in 10 years? All right, so we went over this on one of the slides, and this is in one of the slides, but we'll go over it again. So from equation 5.1, a 6% effective annual rate, which is what they gave you, right, is equivalent to earning. Now you see how they use this equation up here, right? They put a 6 in there, 6%, right? And to the 1 over 12 power, right? Minus 1. Now you can do this because this is an effective rate, right? So we're just applying equation 5.1 here. So this is 0.4868% per month, okay? You'll notice how they take it because it's monthly, it's 1 over 12 months, right? Because they gave this to you annually. This is annually. So you had to make this monthly. So you notice how they divide it by 1 over 12. We can write, so they show you the timeline, and it's clear, right? They said 10 years. So 10 years is 120 months, right? 10 years, 120 months, right? And they want to know how much do you have to save at the end of the 10th year. You want to have $100,000. And as I said to you in the class, we didn't go over an annuity problem yet. We didn't go over the annuity equation. But again, this is built into Microsoft Excel, okay? But the most important thing is, you see the R in this equation, which we'll go over in class a lot more. That R is what you calculated right there. So you took care of most of this problem already by getting that R and putting it here. Now, all you need is, you know that this is going to be 100,000, right? Because you want to have 100,000. So you got to solve this equation for C, which is how much you're going to put in the bank each month. So you divide this by, you divide the future value here by this whole term, so you can isolate a C. You want C all by itself. You see that? So you take this whole thing right here, divide that by, and now that gives you C. So here's the equation, and again, you don't have to know the equation because we used Excel. So here's 100,000, and here's the rate we calculated. And here basically is what they come up with. And here they are using Microsoft Excel, right? And they say if you want to have $100,000 in 10 years, right there, right? You've got to put away $615.47 a month. Thus, if we save $615.47 per month, we can earn interest, and we can earn interest monthly at an effective rate of 6%. We will have $100,000 in 10 years. All right, so I'm going to run this video and see if maybe you'll find this useful too. Here we go.
Valuing monthly cash flows using an EAR quote. The thing to remember about interest rate quotes, effective annual rates, and in a few moments we'll see the annual percentage rate, is that these are interest rate quotes. They do not necessarily correspond to the actual interest earned. From these quotes, you need to calculate the actual interest rate earned. And in this example and the following example, we demonstrate how to do this. So in this example, the bank is paying monthly interest rate, but has quoted this as an effective annual rate of 6%. What an EAR quote means is if you take the actual interest rate the bank is paying, so let's call that R, and you roll the investment over every month in the account, so you do not take your money out, at the end of the year, you will have earned 6% over the year. So solving this formula, we get that the actual interest rate earned is 0.4868%. Okay, so we want to put a fixed sum away each month for the next 10 years so that at the end of 10 years, we will have $100,000. We begin, as we do all problems, by writing out the time. In this case, it's going to be in months. Next, we go to the last chapter and look up the formula we derived for the future value of an annuity. Taking this formula, we rearrange terms so we can solve for the cash flow in terms of the future value. We can now use this formula to solve for the monthly payment, which turns out to be $615.47 per month.
All right, so I wanted to run that for you. Now, I could do the same thing. Let me just bring up Excel. And as we did in class, I'm going to get the payment function up, PMT. See that right there? Everyone see that? That's the payment function. And so the rate is 0.048. Hold on. 0.4868. Let me put a percent, right? 0.4868%. And it's 120 periods, 10 years, right? And in the end, we want $100,000, right? And there it is. That's all I had to do. No equations, nothing. Here's the rate. Now, I got to show you, though, how I had to calculate that rate, okay? So I'll just say, okay. All right? So here's the answer they got in their video, and here's the answer I got. And again, I will just click on this. And there's that equation, right? So now the other question was, well, how did I get that 0.4868? So I had to take that equation right there and put that in here, all right? So let's get that 0.4868. I'm going to put this over here. Remember how you do an equation equals 1 plus Now I could put a cell, oops, that's not a 1, is it? 1, hold on, let me put a parentheses. 1 plus, now I'm going to put the rate, 0.06, all right? I could have put a cell, as I showed you in class. I could have put like 6% here and then just put the cell address there, but I'm not going to do that. And then I raise this to a caret, okay? And I'm going to put another parenthesis so we don't get confused. And I'm going to do 1 divided by 12, as the equation shows, right? Minus 1, all right? Now remember what I'm doing. I'm getting that 0.4868%, all right? If I did this correctly. And there it is. So I just got to go in here and format the cell so you see it as a percentage. Right here, percentage. All right? Now, I need more decimals. Hold on. So we should be exact. We should be exact. Okay. So 0.4868. So I could have actually taken that number and just, right, which is here, and just dumped that into this equation if I wanted to, right? I could have taken that number. So here, let me open this up. That's cell, see how this is cell F1? Let's see if this works. Rate, I'll put F1, all right? And I'll say, okay. And there you go. Now we may be off by a penny or two, all right? But it's the same thing, all right? So that was it for that. So as you can see, what did they get? 615.47, and I got 49. But if I put, well, it's off by 2 cents. But if I put this back as 0.4868%, I'll get. It's just the way it's rounding it off. All right. All right, so that's equation. But you can see, so this is equation 5.1 right there, right here. I got this number. Now, again, don't worry about the future value, but suffice it to say, all you have to do is follow this example, okay? And if they give you an annual rate, you can basically get the monthly rate. This is a general equation, all right? So earning 6% a year effective annually is the same thing as getting 0.4868% every month. Okay, I hope you're clear on that. All right, now I'm going to go on to the equation 5.2, so just hold on. So I'm going to jump ahead here, and here is the new equation, interest rate per compounding period, 5.2, and I'll just read this to you. It's important to remember that because the APR does not reflect the true amount you will earn over 1 year, because you're going to get compounding, right? We cannot use the APR itself as a discount rate. Instead, the APR with K compounding periods is a way of quoting the actual interest earned each compounding period. And you just simply take equation 5, you do this simple division, right? Do this simple division. You then take this, what you do here, and plug that into equation 5.3 here. Now, equation 5.3 tells you what effectively you're getting each year because the money's being compounded. So after I do this division, I plug this into here, all right? Now, I told you already that this equation here, and it's important, is built right into Microsoft Excel. So you don't have to really learn anything. So if I go up here, if I open up Excel, what I want to show you is, hold on, let me go here, is if I type EFFECT, here it is actually. all you got to do is put the annual percentage rate here. So if it was like, let's say it's 6%, and the money's compound, you get your interest every 3 months. You would have 4 compounding periods. And basically, you would say, okay, so this is because of the compounding every 3 months. Let me format these cells for you. You would get 6.1364%. Again, now this is equation 5.3, and this is built into Excel. All you got to do is pop numbers into 2 boxes. You see that? That's to get equation 5.3. Okay? So I just wanted to show you that. Now, to get equation 5.1, that's this. All right? Now, so this combines 5.3. This cell in this equation in Excel combines 5.2 and 5.3 together. You don't have to do anything. So the combination of 5.2 and 5.3 is built into here. So really the only equation you have to really worry about doing longhand is right here. 1.06. Now, the only problem is this isn't built into Excel. Okay, this is not built into Excel. All right. So what you've got to do is do what I did here, okay? And again, this is the future value. I mean, this is the payment of to put away every month to earn $100,000 after 10 years, right? So again, this is 5.2 and 5.3 combined, and this is equation 5.1, which I'm showing you right here. So I hope I'm clear, and your book does that. Okay. So don't worry about 5.2 and 5.3 as long as you know how to use this function in Microsoft Excel. So here's 5.3. So remember, 5.2 is right here. Take this division, put that here, and then just go to, and then all you got to do is use that equation built into Excel. All right. And I think they show you that right here. I think they may. All right, so that's it. This is a long video. It's almost 18 minutes, so let me know if you understand or if you still need more help, okay? All right, everybody, continue.